Today, in this class, I'm going to explain how to find the value of a ceramic capacitor. And before that, let us study the definition of capacitor and the symbols and images of capacitor. Capacitors are available in different forms. This is a symbol of capacitor and two equal size, two parallel plates. And it is fixed capacitor. And see the second one, it is polarized capacitor, and the third one is variable capacitor, and this big one is electrolytic capacitor. These all are ceramic capacitors. Okay, so among the three, fixed, polarized, and variable, fixed means the capacitor value will be fixed, and what is written on the capacitor, that will be, if I measure, I will get that much value of capacitance. So in polarized capacitor, it is one type of capacitor. It has a specific polarity, plus minus, like that. Meaning it must be connected to circuit with correct orientation of its positive and negative terminals. Positive and negative. Long lead always represents positive, and the small lead represents the negative. In this way, we should connect this polarized capacitor correctly to the circuit, with the correct orientation of its positive and negative terminals. That is the meaning of polarized capacitor. These are all ceramic capacitor. And ceramic capacitor, you can read the value from most of the ceramic capacitors. See, look here, 102, 104, 103, 105, 101. So you can read the value from most of the capacitor. The only difficulty to read the capacitors are very small one. Last picture, the very small capacitors, they are very small ones because there is not much space on them to put the value. Here they can't write the value. That means a small capacitor it is. These small capacitors have, all these capacitors have three numbers on them, sometimes only two numbers. So if there are only two numbers instead of three, if there are only two numbers, you will have to read the value directly as a PF. For example, if two numbers written in this capacitor, 10, like that, so directly its value becomes 10 picofarad. So if there are only two numbers, you will have to read the value directly as a PF. For example, if the number 33 is printed on the capacitor, then its value is 33 picofarad. If value 10 is written on the printed on this capacitor, its value is 10 picofarad. If there are three numbers, then it is a method. There is a method to find the value of the capacitor. The first number among the three, the first number represents the 10th place, and the second number represents the unit place, that is ones place, and the third number represents the multiplier. So using these three numbers, how to find the value of the ceramic capacitor, I'll teach you now. So before finding the value of the ceramic capacitor, let us study what is the definition of capacitor. Capacitor is a passive electronic component. Passive electronic component. What is passive? Passive components that do not require any external power source to operate. So passive component that does not require any external power source for the operation. Passive components, they cannot do amplification. Passive components, they cannot generate electrical signals. Passive components only consume, or they only store energy. Such components are called as passive components. They do not amplify, they do not generate, they do not generate they do not require the external power source. They consume only the energy or store the energy. So the important or the common examples of passive components are resistors, capacitors, and inductors. So resistors are used to control the current. Inductors, capacitors are used to store the charge, and inductors are used to create the magnetic field in the circuit. So capacitor belongs to a passive component. So passive component, it stores energy in the form of electric field. It consists of two conductive plates. Look here, it consists of two conductive plates. These two are the plates. It consists of two conductive plates and it is separated by dielectric material. Between these two conductive plates, there is a dielectric material. So dielectric material such as air, ceramic or plastic. So what is dielectric material? It consists of two conductive plates. In between two conductive plates, there is a dielectric material. So what is dielectric material? Dielectric material is nothing but an insulating material. It does not conduct the electricity, but it can support electrostatic field. So in capacitor, dielectric is placed between two conducting plates. So why it is used? Why the dielectric material is used? In order to increase the capacitor's ability to store the charge. So the capacitor will store the charge. In order to increase the ability of capacitor to store the charge, the dielectric is placed between the two parallel conducting plates. That is the meaning of dielectric material. So once again, I'll tell you, capacitor is a passive electronic component. It stores energy in the form of an electric field and it consists of two conductive plates and it is separated by dielectric material. So this is all about the definition of capacitor, and the SI unit of capacitor is 1 farad. The SI unit of capacitor is 1 farad. Farad. 1 farad, how you define? 1 farad is equal to 1 coulomb per volt. So in order to store 1 coulomb of charge, when we apply 1 voltage, and that is called as 1 farad. So 1 farad of capacitance is nothing but 1 coulomb of charge is stored when we apply 1 voltage across the two parallel plates of the capacitor. That is the meaning of 1 farad. 1 coulomb per volt. For 1 volt, 1 coulomb is stored. So that is nothing but 1 farad of capacitance. So it is represented in microfarad, nanofarad, picofarad. So microfarad is mu f, nanofarad is nf, picofarad is pf. Microfarad means 10 to the power of minus 6 farad. Nano means 10 to the power of minus 9 farad. Pico means 10 to the power of minus 12 farad. So this is about the subunits of the capacitor. Now, the capacitor can be measured using LCR meter, using digital multimeter, and using capacitance meter. So, LCR meter, it measures inductance, capacitance, as well as resistance. Digital multimeter, some advanced digital multimeter can measure the capacitance. Otherwise, the digital multimeters measure resistance only. So, in LCR meter, we can measure all three: inductance, capacitance, and resistance. And there is one specialized device. It is designed to measure capacitance, that is called as capacitance meter. So where the capacitors are used? They are used in power supply. They are used in filter circuits in order to reduce the noise. They are used in timing circuit to generate the time delay. They are used in motors to improve the efficiency. And they are used in the tuning circuits. So now I'll explain how to find the value of capacitance. For example, let us take 103. Okay, so first we should write the first two digits. And among 103, first I'll get 10, then 10 to the power of third unit I should write. 10 into 10 to the power of, what is the third digit? Third digit is 3. 10 into 10 to the power of 3. So capacitance in picofarad I should write as the first two digit 10 into 10 to the power of 3. Now I'll show you how to get the value of 103. So 10 into 10 to the power of 3. The first two digits are 10. Multiply it 10 to the power 3. 10 to the power 3 is nothing but 1000. So the total value becomes 10 into 1000. 10 into 1000 is 10,000 picofarad. So 10,000 picofarad, how it is converted into microfarad, I'll show you now. This is 103 ceramic capacitor. On this surface it is written 103. Now we will find the value of this capacitor in terms of microfarad. So 103, the first two digits represents the significant digits of the capacitor. So you write as it is 10. Then the third digit represents the multiplier, that is 10 to the power 3. So you should write as picofarad. So this is the first step. So whatever the number written on this capacitor, the first two numbers write as it is, and the third will become the multiplier, that is 10 to the power of that number you write down. So after that, this is 10 and this is 10 to the power 3. So how much it becomes? 10 to the power 3 is 1000. So picofarad, you can 1 picofarad equal to 10 to the power of minus 12 farad. So 1 picofarad is 10 to the power 12 farad. You write down like this. Next, so this is 1030. So total 4 zeros here, into 10 to the power minus 12, you can split into 2. 10 to the power minus 6 into 10 to the power minus 6 farad. This is same as minus 12. So when both the bases are same, you can add these two. Okay. Then the powers can be added. Minus 6 is minus 12. Next, 10,000 I'll write as it is. This 10 to the power 6 I'll bring down. When you bring down, it becomes plus 6. Minus 6 becomes plus 6 into 10 to the power minus 6 is nothing but microfarad. Okay. Next, I'll write 1 followed by 4 zeros as it is in the numerator. Denominator, there are 6 zeros. 10 to the power 6 is 2, 4, 6 zeros into microfarad. So these 4 zeros and 4 zeros cancel each other. What is left? 1 divided by 100 microfarad. 1 divided by 100 is 0.01 microfarad. So 103 is nothing but 0.01 microfarad. Okay. So this is about converting into microfarad. Now you can convert the same thing into nanofarad. Okay. So 103 you can write as first two digits into 10 to the power 3 into picofarad. Always the number given on this capacitor, it is a picofarad value. Next, this is 10 into 1000. Pico is replaced by 10 to the power minus 12 farad. So this is 10,000 into, now I want to convert this into nanofarad. Nanofarad is nothing but 10 to the power of minus 9. So I have to split this into minus 9 and remaining value. So 10 to the power minus 3 into 10 to the power minus 9 farad. Because when base are same, numerator power, if you add minus 3 minus 9 is minus 12. In this way you should split it. Next, 10,000. 10 to the power minus 3, you bring it to down. It becomes plus 3. 10 to the power minus 9 is nanofarad. Okay. 10,000 divided by 10 to the power 3 is 1000 nanofarad. 3 zeros cancel each other. What is left? 10 nanofarad. 103 is nothing but 10 nanofarad, or 103 is nothing but 0.01 microfarad. Now we have another capacitor. This is 104. Okay. So I'll write 104. So how 104? It will be in the form of a picofarad. So how to write? The first two digit write as it is. The third digit will be the 10 to the power 4 picofarad. Okay. So 10 into 10 to the power 4 is nothing but 1 followed by 4 zeros. Picofarad, you want to convert 104 into microfarad. So picofarad, you just write 10 to the power of minus 12 farad. 1 pico is nothing but 10 to the power minus 12 farad. So here 1 0, here 4 0. So I should write 1 5 zeros into. I want to convert this into microfarad. I have to split into minus 6. 10 to the power minus 6 into 10 to the power minus 6. Okay. So this 10 to the power minus 6, I'll bring it to the denominator. So 1 5 zeros divided by 10 to the power 6. So what is left here? 10 to the power minus 6 farad. 1 10 to the power minus 6, I have brought it to denominator. So 1 followed by 5 zeros I'll write as it is, divided by 10 to the power 6 is nothing but 1 followed by 6 zeros. 10 to the power minus 6 is nothing but microfarad. Okay. So here 5 zeros, here 5 zeros cancel. What is left? 1 divided by 10 microfarad. That is 0.1 microfarad. 104 is nothing but 0.1 microfarad. The same thing I'll convert into nanofarad. So 104 is equal to 10 into 10 to the power 4 picofarad. Okay. So 10 into 10 to the power 4 is 4 zeros. Pico is minus 12 farad. 1 pico is nothing but 10 to the power minus 12 farad. So here 4 zeros, here 1 0. Total 5 zeros. Into. I want to convert this into nanofarad. Nanofarad means 10 to the power minus 9. So I should split this as 10 to the power minus 3, 10 to the power minus 9 farad. Okay. So 1 5 zeros, 10 to the power minus 3, I will bring it to denominator. It becomes plus 3. So into 10 to the power minus 9 is nothing but nanofarad. So here in numerator there are 5 zeros. In denominator 10 to the power 3 is 1000 nanofarad. 3 zeros cancel each other. So what is left? 100 nanofarad. 104 is nothing but 100 nanofarad. 104 is nothing but 0.1 microfarad. Similarly, you can do for 105 capacitor and 102 capacitor. I have solved for 103 and 104. You do it for 101, 102 and 105 and write me the values of these three in the comment box. I'll tell you they are correct or not. And if the disk has only 2 digits, suppose this is your disk. If only 2 digits are written, if there is no third digit, then directly this becomes 10 picofarad. If the disk has, for example, 33, then 33 picofarad. If there are 3 digits, then you should follow the above procedure to find out the value of capacitance.